Welcome, everyone. I'm Priya Natarajan, an astrophysicist on the faculty in the departments of astronomy and physics at Yale. I also serve as the current director of Yale's flagship interdisciplinary program, the Franke Program in Science and the Humanities. I'm delighted to have you all attend today's wonderful talk by neuroscientist and author Mariano Sigman as part of our ongoing Mapping as Knowing series. I want to first start by recognizing the generosity of Mr. and Mrs. Richard and Barbara Franke for endowing this program and many other activities at Yale. As a quick point of reminder, since we are recording this event, I would like to request you all to mute your videos and microphones. Please go ahead and submit your questions for our speaker through the Q&A feature. Dr. Ty Camp and I will relay these questions to him after the talk. So coming to our speaker today, Dr. Mariano Sigman is an eminent neuroscientist with well over 150 publications in some of the most prestigious scientific journals. He's extremely research active. He's also very passionate about experimentation and has worked on an unusually large set of collaborators that might sound really peculiar and intriguing: magicians, chess masters, musicians, athletes, and visual artists, to bring his knowledge of neuroscience to different aspects of human culture and activity and apply it in different contexts. He has participated several times in the TED Global events in Vancouver. And in one of these instances, he participated with Dan Ariely. In his conferences, he teaches how the mind works and what lessons we can learn about decision-making, leadership, team management, personal development, or creative skills. And his presentations always end up with sort of a high level of participation from the audience through experiments and gamification. Dr. Sigman obtained his degree in physics from the University of Buenos Aires, his doctorate in neuroscience in New York, and he did a postdoc in cognitive sciences at the Collège de France in Paris. In 2016, he was awarded the PO11 medal from the Pontifical Academy of Science, which is a major science prize, and previous winners include Stephen Hawking and many notable Nobel Prize winners. Beyond the academy, his research has had practical implications for medicine, for treatments, clinical treatments, for example, in the diagnosis of vegetative or autistic patients. And he's also had a lot of impact in education with effective interventions to improve decision-making and learning in schools throughout Latin America, and in art with a project, The Morphology of the Look, that has been exhibited now in New York, Austria, Moscow, Mexico, Japan, and was part of the 2017 Venice Biennale. He's also developed an extensive career in the public dissemination of science that includes multitudes of TV programs, hundreds of articles published in different editorial media. He's also the author of the bestseller, The Secret Life of the Mind. I highly recommend this book. Absolutely fell in love with it. It's just beautifully written. Before turning over the floor to him, I would just like to remind you all about our Learning by Doing project. Please do consider submitting your videos to our collection of simple science experiments. And our final talk in the Inference series will be given by physicist Kyle Cranmer next week on December 15th at 3 p.m. So without further ado, I would like to turn over to Mariano. Welcome. And we wish we could have welcomed you in person in New Haven. We had been postponing get your talk, hoping that we could get you in person, but then ultimately decided that we didn't want to wait any longer and that we're dying to hear you. So look forward to your talk. Thank you.
Thank you so much, Priya, for this such a warm introduction. I also would very much like to be able to be there. I went to New Haven when I was a child. My aunt, she was a neurologist, and she worked there at Yale, actually. And I went there as a child, and I, you know, how we build these child memories of these places, you know, as a bit mythical. For me, my aunt was a huge intellectual and a great neurologist, and this place was the place where, you know, great scientists went. And I've never gone back. Interesting. Like I spent many years in the US in academia, and I've been in many of the main universities, but I just brought this memory that for some reason I never came back to Yale. And I very much hope we'll have the opportunity. I would very much wish to go there
really
again.
Hope so yeah, we look forward to your visit in person.
This has brought me a very emotional memory from my childhood. Okay, so I'm going to speak about decision making, but because this series builds on the relation between mapping and knowledge, I thought it would be interesting to begin not so much with the science of decision, but the other way around, how science has helped us make decisions in difficult domains. I think this has been often a role of science to bring relevant data for having informed policies and informed decisions. And this has happened in all fields of knowledge. And of course, this includes neuroscience, and especially the bridge or the relation between neuroscience and medicine. And Priya, you mentioned like the work we've done on diagnosis of vegetative state patients. I think this is a very clear case where many years ago, there was not much that could be done because essentially we were looking at the void, and technology has changed in a way that now we have the capacity to be able to infer thoughts of other people by looking at their brains. And this is a technology that may be flashy and interesting, but it gets really relevant when this is the only way that we have to communicate with some people. And this happens in three very peculiar domains. One is patients, comatose patients, so patients in vegetative states where it looks like they are unconscious, but we are really not sure if they're unconscious. They do not express consciousness, but of course that doesn't mean they do not have consciousness. Another example I'll be showing some data is on babies when they're preverbal and they cannot communicate their minds. And as parents, we do like all what we can to understand what they feel, what they want, what they suffer, what they would desire. And we do this exercise of complicated inference where once again, technology now can give us a good hand. And the third case, which I will not be speaking today, is dreams, which also remains, I think, one of the very interesting frontiers of knowledge in human neuroscience. So let me start with work done by Adrian Owen. This is an extremely classic paper. It has now 25 years. And what you're seeing there is the image, the brain image by fMRI of a group of people. This is the average image, and it's been thresholded. So the pattern, of course, would be much more complicated. But what you see on your left of the screen here is what activates when someone imagines that plays tennis. And this is nothing special about tennis. It has to do with motor actions. So what you see here lighted is a region in the brain called the supplementary motor area. And this is a region that is involved with the coordination of movement. But even if we do not enact these movements and we just imagine them, then this region also plays the same role. It's like a music director that's directing the concert without it sounding. And on the right, you see how the brain of a person activates when they close their eyes and they imagine they are walking in their houses, or they're walking in the Yale campus, or they're going from their house to their work. We have a very significant capacity. This comes from our ancestors, rodents and all mammals, to navigate in space, and there are brain regions that are dedicated to this. I'm not so interested now in the brain science of these specific functions. What I'm interested in is that now, if you see this from an engineering perspective, now what we have is a utility, a tool, a technology that somehow we can tell very rudimentary what the person is thinking just by looking at their brains. So if I would let think whatever you want, either that you're playing tennis or that you're walking in your house, then I could tell with very high probability what is actually what you're thinking just looking at your brain. Again, this is not very useful. I could just ask you that. But once again, we come to the vegetative state patients. We cannot ask them about their thoughts, but somehow we can prompt them to make thoughts and then ask what happens. And so vegetative state patients, they have been, in the public scene for many years now. And the reason for this, there are two reasons. The first one is a purely medical reason, which is that 20 years ago, these patients arrived in a coma to a hospital and their likelihood of survival was very low. Now they survive, but they do so in a situation which, once again, is a huge mystery about what goes on. And it's a situation which, of course, leads to a lot of ethical problems and a lot of suffering. And so Adrian Owen redid this experiment now with one patient that had been 5 years completely uncommunicated, and with the idea that she was unable to make explicit thoughts. What if she could, but she could not communicate them? Could it be that reading their minds by MRI, we could detect that? And that's what Adrian did. And what he found is that when he asked this patient to imagine that she played tennis or that she moved, apparently she heard this message and she reacted and she enacted this motion, and the same thing with spatial navigation. Of course, we do not know whether they're conscious about these thoughts. It could be that they're unconscious, but at least we know that they understand something and they can react to that. And once you have this tool, this is an engineering device that you can use now as a binary communication device. So you can say, whenever you want to say yes, imagine that you play tennis. Whenever you want to say no, then imagine that you are walking in your house. And as any communication device, you want to calibrate it, and you want to calibrate with things that you know. So you'll ask questions like, are you a woman? The answer is true, so you expect the answer to be yes. Are you younger than 23? And the answer is no. Do you have 3 siblings? The answer is no, and so on. And once you have calibrated this communication device, which is far from perfect, but it's also much better than chance, then you can start asking the questions that you would like to ask. Are you suffering? What would you want? What would you wish? What would you want us to do? And then we go to a completely different sphere. It's the sphere of ethics, but it's one that's nurtured or that can be fueled by data that can be provided by science. This is, of course, a very important but also a very tough example. Let me now give you a much candid one which I think we all, at least for all of us that are parents, we've gone through this experience. So what you're seeing here is, again, the same strategy as I showed you before. First, the brain of a person in which the experiment is, so to say, easy. And this experiment is just the person listening to sentences. So it could be, you can imagine this as what happens in your brain as you're listening me to speak. And what happens is that you see this pattern of activations in these 2 big regions. This is the auditory cortices. And of course, the auditory cortices activate when you hear sound. Also, interestingly, I cannot go into details of this, but you see, even if this is an old paper, we were pushing the limits of temporal resolution. You may know that if MRI is pretty decently good in spatial resolution, you can get these maps which have like millimeter resolution, but the temporal resolution is very low. And cognition happens, in a fraction of a second, and suddenly you have, a tool that actually had a resolution of a few seconds. And so we were in the frontier of this, and what you see here in different colors is not the amount of activity, which is what you typically see in an fMRI image, but the timing of activity. And you see going from, this is measured by the hemodynamic signal, which is the MRI response, and the phase of we can measure the phase of this signal by the convolving the response function, and we could compute with this, or we could infer the temporality of the responses. And what you see, once again, this is a very fast summary of something that could be the entire talk. You see that there's an early activation in the auditory cortex, which projects to this region in the frontal left cortex, very famous region, you may have heard about it, called the Broca region. It's named Broca by the French neurologist, Broca. And this region is known to be relevant, and it's one of the very highly specialized regions in the brain, which is specialized for the articulation of language. So if you have aphasia, which means that you can understand language, but you cannot produce language, then typically you will have lesions in the Broca. In people that have aphasias have lesions in the Broca region. Now, if you've been following the logic of what I said, there's something that may seem a bit strange, because I'm saying this is the brain, the activations in brain of people listening to sentences, and yet they're activating one region which is known to be very specialized for the production of sentences, which they're not making, they're just listening. Well, as it happens, with something that we've discovered, and it's the field, I mean, not me nor my lab, the entire field, is that there is a whole system of resonance called the mirror system in the human brain and in the mammal brain, which is that essentially we internalize all the actions we perceive by enacting them somehow. So in a way, when we hear 2 sentences, we're also producing internally and silently these sentences. A little bit like I showed you in the previous slide when I said, when you imagine that you're playing tennis, you're not moving the muscles, yet you're enacting the entire motor concert. Now, the question is, what happens with young babies when they listen to sentences? Because it's not that they will not, produce language, it's that they can't. I mean, they have 3 months, they are still, they have to quadruple their lifetime to arrive to the moment in which they'll begin producing their first words and sentences. So is a preverbal baby very far from the moment of the initiation of production of language, silently producing language? This was a philosophical question, one that was not amenable to science. Now we have proxies. We cannot completely answer this question, but we have good ways of addressing this question, which is repeating this exact experiment in babies and asking whether is their Broca region already being activated, the region that actually works in the production of sentences. And now what you have is a summary of 3-month-old babies. Once again, for those that have not experienced with babies, they're very, very far from producing language, and yet on a way they're trying. And this was, to me, I would like to present something which for me is very important here, which is in the moment this experiment I did just before I had my first child. And I thought it was very important because I think in a way, a very essential thing of parenthood is that we try to detect the struggles that our children may be undergoing, and we help them. So if they're struggling with walking, we'll give them a hand. If they're struggling with eating, we'll help them on that. But of course, they're going through a myriad of struggles that we will never see because they're opaque, they're silent. And I really like this experiment, not only because of its scientific pertinence, but because I thought it communicated me better. It's kind of what I like most of neuroscience, which is this capacity of getting closer to the people that we would like eventually to get closer. So in a way, what this told me, kind of short story and a bit exaggerated of this result, is that in the same way that a 9-month-old baby is trying to walk and they're struggling, a 3-month-old baby, although this is silent, they're trying to speak. They're trying to make their first words. And so I accompanied and I walked with my son on this particular process. So this is just a way also on how science may begin us informing on policies for education. Now, not education in school, but maybe an even more relevant form of education, which is parental education. So this is the first part of my talk, and it has kind of a different flavor because once again, it's not so much the neuroscience of decisions, but it's the neuroscience that can help us or will give us information to make better decisions. Now I would like to go to like a completely different space of decisions, which is the ones we do not have this technology and this much information, the majority of the decisions we make, which is somehow we have the information that we have, scarce information, often not enough, or sometimes even like no information, and we have to make the best educated guess from what we have. So let me give you a first examples of what we humans do when we are confronted with this type of decisions, and then we'll go into the science of it, and then we'll go on to how we can improve some of the biases and some irrationalities that we tend to make in these decisions. So this is a very classic experiment. I love this experiment, and I would like to do it with you on stage. It would be much more interesting because we would sense it on a much better way. But it's a very classic demonstration. The first kind of scientific paper was published by Ed Hubbard and Ramachandran at UCSD, University of California, San Diego. And the question is like, these are two shapes. One is Booba and the other one is Kiki, okay? So one is Booba and the other one is Kiki. You know which one is which, but the task for you, decision makers, is to tell me which is which. You can do this in the chat if you want. So you get a feeling, I don't know if you have a public chat. If you do, then you could do it. And then you may have kind of a public sense of the agreement that there is in the response of this. Typically 98 or 99% of the people agree that this is Kiki and this is Booba. And this is quite interesting because it feels like completely obvious, as if it could not be in a different way. Yet when we're asked like, why is the case, it's just very hard because there's no reason for that. Some people do see a K here, but if I would say Titi instead of Kiki, then it would be the same thing. And the reason is known. The reason is that when we make sounds, we move the mouth. And when we move the mouth builds different shapes. So when I go like O or U, those are actually, they're called rounded vowels. And so we think that these sounds correspond to rounded shapes. Instead, when we make like these sounds in which the pale contracts in a sharp way, like P, like T, like K, then we imagine that these sounds are kind of attacking consonants and are the ones that have sharp angles. So this is when I say like there is this correspondence, by no way I mean that we are making this conscious logical inference. I'm saying the brain is doing this calculation. We're completely unaware of it. It biases our decisions in an extremely predictable and reliable way, yet we are completely unaware of this entire process. Now, this looks like a game and it doesn't look very important, but let me give you an example which I think it's much more relevant, and you'll see how these same ideas start forging our decisions in domains in which we maybe would not like them to do so. And so here, this is, once again, I mentioned Alexander Todorov, he's in Princeton, and I didn't point to a specific paper because it's kind of a collection of papers, and this is my own demonstration from his story. So he's the reference that you can look at any of his many papers. He's been showing how we make judgments about people of all sorts from facial expressions. And the way I like to frame this experiment is, imagine you have a suitcase with like the most important things in your life. Actually, an interesting experiment is, what would you put in this particular suitcase? Like what are the most important things in your life that you would put, in a small space? But imagine you do have so, and for some strange reason, it doesn't matter here, you need to leave this suitcase with the most important things in your life. And you're confronted with the situation. You have to respond very rapidly, and you have to decide, like, there's these three persons here. You could think this as an investment problem. You have your money, you choose what bank to put it on. And each of these is one bank. This is like the technical way of thinking this experiment. The more real way would be, you have something, a real thing, and you have to give it to one of these three people. And the question is to whom you would give it to. And here, it's not such a sharp distribution as we saw before, but there's also a very significant trend that's observed in children, in adults, in America, in Europe, all over different cultures and so on, which is that the majority of the people prefer to give it to the person in the center. And the reasons why they do not give it, some people do give it to the person in the right and some people to the person in the left, but the reasoning beyond this particular decision is that the person on the right, we do not trust him so much. Like, we have the impression that we may come back and ask for our suitcase, and he may go, you know what, I like your suitcase and I will not give it back to you. And we do not want to go through this confrontation with this particular person. The reason why the majority of the people do not give it to the person on the left is very different, is we think he's like so naive that he will give it back to us, but maybe he will give it to anyone and he will lose it, or he will be stolen our suitcase. Now, the interesting thing is, I mean, I think you get the point that the majority of us do make these very fast and rapid inferences. And the interesting point is that we have no idea about these people. We have not a single piece of evidence about how they would behave. Yet we make conclusions, and conclusions in which the majority of the people is highly confident, really trusts this impression of what the right action should be. It could be, it's possible, it's not impossible, that the faces of, actually you can see also that it's the same person that has been only changed the curvature of the mouth and the eyebrows and so on. Now, it could be that there is a correlation between people's faces and people's attitudes. I mean, this is not impossible, but it's not true. I mean, the Nobel Prize Kahneman, also in Princeton, has shown many times that these correlations actually do not hold in any way. And so the conclusions that we make so strongly by people's appearances are completely ungrounded, and they lead to completely wrong decisions in which we deeply trust. Now, the example of Kiki and Buba was kind of game. This is very relevant because, for instance, it's known that the face of a person shapes elections. So if I were to show you two candidates of like a completely unknown county of Australia and ask you who you think will win, you'll be kind of at 55 or 60%. And what this means is that only by the information in the face is what the voters are using to make their choices, because you have no idea of who is a Democrat, who is a Republican, who is progressive, who is conservative, who has a good history. No information at all. Only with information of the face, you can make this sort of conclusion. Also, it's very well known in human resources. The majority of the people decide who to hire on the first 500 milliseconds of an interview. And then they spend 20 minutes only to justify the decision that they have already made. So I've given you 2 examples. I could give you 20. I mean, there are millions of, there are funny examples, on how we make this kind of what's consistent about all these examples is how we are very stereotypical. People call it irrational. I don't think it's irrational because there's rationality, only that we are doing rationality on the wrong grounds and on the wrong evidence and on the wrong information. But there's a kind of a smart inference process, but that takes us with very high confidence to wrong conclusions. Now, what I would like to do is to tell you how this process builds, how we actually build these intuitions. And once again, I'm bringing you some classics of the field. This is an experiment that you see now has 20-something years. It was done by Behara and Damasio, very, very famous experiment, in which they try to understand how we construct these hunches and these unconscious intuitions. And I think it's a very beautiful experiment. So let me tell you exactly how it goes. So it's also an investment experiment. And the way it goes is that people are given 2 decks, and these decks have payoffs. And these payoffs can be either positive or negative. You can win money or you can lose money. So it's kind of a simulation of you have to choose between 2 portfolios in the stocks. You can choose between them, and sometimes you'll win, sometimes you'll lose. And you'll try to do some statistical learning to understand, on average, what's the right policy. And that's what people do. They choose from one, they win, so they persist. This is very typical. Then they win again, they persist. And we make this inference that if we've won, there's no reason to explore, which is not optimal, but that's what people do. If you're winning here, you're very unlikely to go elsewhere. Eventually you lose, and then people do the contrary. They overswitch. And so they go to the other deck and they play here for a little while, and then they lose and they switch and so on. And after an hour of play or something, they reach this moment here, which is the conceptual moment. It happens that one of the decks has a highest average of return than the other one. And so this is what's called the correct choice, because it's the one that on average, if you continue playing on this, regardless of this stochasticity, which you cannot control, it is the policy that will give you a higher expected value. So in the end of these many trials, people choose from the right deck. And when you ask them why they're doing so, they explain exactly what I just showed you. Well, you win, you lose, but on average, this one is better than the other one. So they have understanding, and they understood the problem perfectly well. What's interesting is how is the path to this particular moment. And some trials before that, there is a moment that Damasio calls the hunch moment, which is the following. People play from the right deck. And if you ask them what they're doing, they say, well, I'm playing from this one. I'm choosing from the right. Why? Don't know. I have like this feeling that's the right thing to do, but I cannot tell you why. I mean, it's just kind of a gut feeling, a hunch. So there you understand the genesis of the gut feelings. They have nothing esoteric, nothing mystical, nothing irrational. It's a full-blown statistical learning process, which yet has not come into words. And so the brain has learned something, and there's no mystery on why it has learned something, because it had the statistical information to learn it. But this knowledge, as the majority of the knowledge we have, cannot yet be explained in a way that we can teach it in a lecture. It's not explicit knowledge, it's implicit knowledge. So with this, I would like to give you a feeling of what intuitions are. Intuitions are essentially a form of learning, statistical learning of different domains and different scenarios and different portions of the universe, which yet we have not made to explicit knowledge. Now, there is an even more interesting phase, which is what Damasio calls the pre-hunch, which is the following. In this phase, people, as you see, are choosing on average a little bit more from the correct deck than from the wrong deck, but they don't even know they are doing that. So if you ask them what they are doing, they will tell you, I'm just picking a chance. Like I'm going one and the other one I'm trying to learn. There's like no information, no structure. That's not what they're doing. They're picking more from the right one. The brain has catch this information. This has not yet come in terms of body expressions of wrong and right decisions. So there's not even this information, but they do have this information, which then builds into a hunch and then builds into conceptual knowledge. And the second thing I would like to go on this kind of fast sweep through decisions and their idiosyncrasies and the typical things that we do wrong and when they are right and so on. By the way, let me tell you something which there's no way to respond completely this particular answer, but something that typically comes into a very popular question, so to say, is what's the right way to decide. And by the right way, I mean in terms of category of ways of making decisions. And a classical split is between people that think that you should follow your heart or your intuitions, and other people that think that you have kind of to go all the way in your decisions to write them down to the last decimal and calculate all what you can. And I think that this tells us very clearly when hunches are good and when they are bad. They're good in domains in which we do have a lot of statistical information. And there are some domains that this is true for the majority of the people. One typical example is social knowledge. We all have a lot of experience on how people behave. And so social knowledge rightly works on the ground of intuitions. And it will be complicated to choose who you like to spend your life and so on by, very detailed calculations, although algorithms now are trying to do so for us. But the best resource we may have for this highly variable problem, highly dimensional, that cannot be reduced to simple calculation, is to use broad approximate statistical learning. Other decisions like piloting a plane or doing surgery, of course, we want a very highly precise and educated and rational decision-making. So this also tells like the typical fallacy that some people think that they have very good intuitions. And this is never true. Some people also think that they have very bad intuitions. This is also not true. People have good intuitions for certain domains in which they are educated statistically, and they have bad intuitions for domains in which they are naive. So a tennis player will have good intuitions in tennis. Maybe a farmer will have good intuitions on weather because that's something that's relevant for them and they've looked at them a lot and so on. And different people have good intuitions about different domains. Now, last thing I would like to show you is the idea of confidence. And this, on the questions, we can go more in detail. And once again, I'm going to make a very, very short excursion, a very short trip in this particular domain. Let me just have water, sorry. I like this quote by Woody Allen saying that this idea that we should be confident when we know a lot about something, but that's not what happens. That's what I showed you here. We tend to be very confident when we know nothing. And so we just get, glimpses of the data, but because this is all the data there is, we forget that there's a lot of ignorance. And so we are extremely confident by spikes of data. And so this is captured by this idea is confidence is what we have before we know a problem, because when we know a problem, we know the complexity of the problem. And we know that we should temper our confidence. We may understand more, but the first thing we discover is not understanding, but also the universe of ignorance. And the prettiest demonstration, I think we have ourselves, my lab, a lot of demonstrations, but there's this demonstration by Ranev, which I really like. And I thought also in this mapping symposium, it was interesting also to bring this different technology, which you may be, it's also pretty popular now. It's called TMS, transcranial magnetic stimulation. It works through Faraday law. So there's a very rapid magnetic field that's induced, and this induces a current. It's a very weak current, but it's enough to make a pulse in the brain that can do different things. One thing is this pulse could be in the motor cortex, so you can, it can move your hand. And this is very intriguing because you feel a little bit like a puppet because there's someone that's actually controlling directly from your brain and moving your hand. You can also go onto language regions and induce the production of language, but also you can just produce or build noise in the brain. So kind of a scattered current that what will do is bring noise. And so if this conjecture is true, then there is kind of a very anti-intuitive prediction, which is that as you increase the noise in a problem, then you know less and you will perform worse, but you will be more confident. And this is a typical situation in which people, we recognize these people tend to be very confident in highly volatile scenarios. Once again, because they ignore the variance, and then there are very strong spikes of data which they grab, and they feel very attached to this particular subset of the data. And so what you have here is a performance on a perceptual task. It doesn't matter the details. And as you go higher in the bar, this is D prime, which is kind of the measure, statistical measure of the performance. And this is different people. And what you see is people vary in performance. And this on blue is the average. And this is yet not too interesting. Then you put noise into the brain and you ask what happens with performance in this particular person. You put noise in the visual cortex. What happens is that people do worse. And this is what you'd expect. This is just kind of not very interesting, but at least the method works. You make people do something and you see that in every single subject, they do worse when you're injecting noise than the black condition. Actually, there's also it's kind of a control because there's the same sound and the same situation, but there's no pulse of current. And now the question is what happens with confidence? And you can see the comparison here, which is that in a situation in which people do worse, which is the red one, people are more confident. So this person is doing worse, he or she's more confident. This one is doing worse, but she's more confident. And the same true for every single person, except for this one here. So you see, once again, a demonstration of an idea, which I think is very interesting and can be mapped to a simple concept, which is we tend to be very confident when we know nothing about something because we know nothing about the ignorance that we have about this particular space. And this is what happens very often in decision making, which is that we have to make a decision. This decision involves many different spheres of knowledge. We are just looking at a particular subset of the data. We do logic here and we do good inference here, and then we are very convinced. But then someone else is looking at a different portion of the data, and they're also doing good logic on this particular portion of the data, but ignoring the rest of the existence of the data. And so they come up with a very different conclusions. And this builds to what we've seen now these days, which is that people suddenly cannot understand each other, and they come to completely different conclusions where the world seems to be completely polarized to a point that people seem not to be able to speak one to the other one. So I want to go there on like my last slides is on how we can correct this. Once we understand this phenomena, how we can correct. And it turns out to be that there's an extremely simple solution, not rocket science, very, very simple solution, zero technology, which is a significant game changer, which can improve a lot the decisions that we make in simple decisions, like, making, easy calls, but also in the most complicated decisions of our lives. So this comes from an experiment that we did on a huge audience. This was done in a basket stadium with 10,000 people. What I will show you is that what we had, the idea that we are trying to probe here is that if the hypothesis is, as I told you, that people make bad decisions because they only look at subsets of the data, then there is an easy way of correcting this, which is putting people together. Because together they are sampling at different portions of the data. And so they're getting a better understanding of the errors of reasoning that they're making because of looking at partial data or making conclusions very rapidly and so on. And so there's a simple idea, which is that if you get together with people to think about a problem, then you'll come up with better decisions, not just better in quality, but also more equanimous and more balanced decisions. And so this is what we wanted to do. And so what we asked is people to make decisions, and then we brought them together in groups of 3 and 5 people. The number is very important. I'll explain in a second why. And then people made together this call, this decision, and then they had the opportunity to change their mind. And our question was very simple. What happens in this? You can see this kind of as a filtering process, like a coarse graining process. You have an idea, then you have a kernel, like in deep learning, you have a kernel of different peoples and you lose statistical information, but somehow you gain resolution or you gain a precision. Sorry, you lose resolution, you gain precision. And the question is what happens? And so we did this experiment, which is, as I said, I think remains the biggest public presential experiment in decision making. It was very beautiful because there was a particular noise. You see here on the right how it went. Like each one of these is a group of people that were conversating about things. Sometimes like kind of easy things to conversate, but also sometimes very difficult and things that we struggle a lot to put into words and to discuss with other people. So the first part of the experiment is very simple. It was kind of approximate questions, and this we wanted it to be a model of like the majority of the decisions we make. We have partial information. So one question could be how many cities are there in the world with a population larger than 1 million? Or the question could be how many times do the Beatles say yesterday in the song Yesterday? Or the question could be how many goals were scored in the last football or soccer World Cup? Or the question could be how many airports are there in the US? For all these questions, you have an idea. You know more or less how many they are, but of course you do not have the exact answer. And if you think these problems as investment problems, the more precise your calculation, then the more likely that you will make a better call. And so people made their call, which, I mean, you can do yourself. You can give a try here. We cannot play the game. I mean, if we were together, then I would do this experiment with you. I would ask you, to think about it, then to get together in groups and so on. But that's something that unfortunately we cannot do here. So the answer for this one particular is 496. And so what we did is we looked at what happened. And something I like to tell you is that data here, people wrote this in a paper. They used pencils and paper. So nothing sophisticated. And actually our data set were huge garbage bags, huge garbage bags with thousands of papers, which we took and then we digitalized and so on. And we converted this into science. So what you see here is kind of what was the norm by then. And the norm was a very simple statistical idea, which is that if people are unbiased, which is true for a certain class of problems, then the more people you get, the better it will be your result, essentially because there will be noise canceling. This is not a statement about people, it's a statement about statistics. So it's convergence to the mean. So some people will think there's more, some people will think less, and as you get more and more people, these things will cancel and eventually you will converge to the mean. Now, because there were many questions and questions had different units, they refer to different things, you have this expressed in terms of normalized errors, and you see that it does not converge to zero. And the reason it does not converge to zero is because people in many questions, they are biased. And so the majority of the people think that there is more than actually there was, or there was less, or they either overestimate consistently or they underestimate consistently. And this is something that cannot be canceled by aggregating more and more people. And the question was, what happens when we get people together? So there was imagine there was 1,000 people. So we had 1,000 votes. And then we get them in, we can look like coarse graining. As I said before, we can get them in groups of 5. So now we have only 200 groups, but each group has a better decision. And so the question is this coarse graining efficient or not? And the answer is it's highly efficient. So you see it here, which is that actually when people get together, they converge to a decision which is much better than the decision they had before getting into the group. And this made a lot of noise, although it may seem very simple, because there was kind of a very strong belief. If you think this from a statistical perspective, once again, for a system to be sound statistically, you want particles to be independent. The moment they get correlated because they start talking to each other, then you lose statistical information and then you get kind of redundance. And then instead of having 1,000 votes, you have less votes. But what we were showing here is actually that the value of conversation actually was greater than what you lost by this coarse graining. And this changed an idea that had stood for many, many years, which was that to make good judgments, you need people to remain independent. They do not need to influence one to each other through conversations. And actually, when people came back to their seats and they had the opportunity to change their minds, this result was even much better. This is what you have here, which is the standard error of individual votes after they have been filtered through conversations. So let me put all of this together. I showed you in the first part that our decisions are very biased and they have all these errors of reasoning. We only look at part of the evidence. I could not show all of them, but I showed enough that I hope was convincing that we make kind of these stereotype errors. And they're a problem precisely because they are stereotyped. We are not aware of them. And how can we be aware of them in the moment you have to explain this to someone else? So we asked, what is it that people are doing when they get together? And what we saw, the first thing is that, if you take all the results, imagine that you have a group in the number of cities, and there's a 400 or 480, and someone responded 700. The first thing you could do is just average, and this is good enough. And if you were to do this, then you would get the blue curve. But the fact that the black curve is better than the blue curve is showing that the groups are doing something better than average. And this is interesting because we did not give groups any policy. And yet it turns out that groups are smarter than they would be just by, pulling their information together in the most classical way. So if you look at all possible mathematical models, what you get is that what people do is optimal statistically, which is that they tend to combine information of everybody, but they do so on a way that's weighted by the confidence. And so this is a weighted average by which you give more value to the person that claims to know more and less value to the person that actually claims to know less. Second typical robust statistical thing is to identify where this is good calibrated. So you try to see if the people that have high confidence, and this I do not have enough time to dwell on, we can go into this into the question, are kind of imposters that will have, and the way people do that is because they have high confidence in all questions. So if someone claims to have high confidence in all questions, then the group do not use this confidence information. But if they do so on some questions, but not others, then they begin to use informations. And finally, of course, from this average, they filter outliers. So if someone would say, that there are like 3 million cities with more than 1 million, with more than 1 million people, then groups would say, we do not take this information in the average because it would completely destroy it. So this is interestingly enough. But I don't have this information here, but if I were to put the confidence weighted average, it would be somewhere between the blue line and the black line, but people do even better than that. People do even better than the best mathematical model to combine the results. And the reason is that people do not combine the results. They combine the methods by which they reach those results. So they discuss, well, how did you think this problem? And then they go, yeah, but you made an error because look, in Europe, cities are not so populated. And they begin questioning actually the arguments and the reasons that were kind of hidden in the unconscious. And that becomes just kind of a monitoring process by which you make explicit all the arguments that lead to this decision. So very simple, but very powerful. Is a healthy way of making good decisions and avoiding these biases. Is just whenever you have to make an important decision, you look for someone else. Cannot be 300 people because that's not a good conversation. It has to be 2, 3, or 4 people. Ideally, they have to think different from you so that you will be forced to explain them the reasonings that led you to this particular choice. And on doing so, you are very likely to find errors that would have remained completely unconscious if you did not go through this particular filtering process. I like to tell you something else because I mentioned the idea I could finish here, but I would like to tell you one more experiment. This is the one we did with Dana. We also did it in a group with 10,000 people, and then we did at TED with Dan Ariely. And here the question was very similar to the one I just presented, but it was not on questions that have a ground truth, but on questions that actually are more in the domain of morality or ideology or politics, those things that we just strongly believe they're right or wrong. And those things that, as I said, are very polarized. And some people have very strong arguments that make them believe for A, and some people have very strong arguments that make them believe for B. And apparently, there's no way, and even less and less way of putting this together. I would like to make here the claim that this is not an inevitable phase of human dialogue and human interactions. It's just a consequence of conversations happening in the wrong space, which is typically the space of social networks and the space of a lot of people shouting at the same time. I want to make the claim, the scientific claim, that when people get together in small groups, then they become more equanimous, they become much more malleable and much more open than they actually think they are. So the way we did this experiment is we had dilemmas. And this is just one dilemma. And you'll see they're kind of uncomfortable, these dilemmas. You can read them. And so a company offers a service that takes a fertilized egg and, sorry, I'm not seeing the right part because and produces millions of embryos with slight genetic variation. This allows parents to have a child that shares their combined genomes, at the same time selecting their child's height, eye color, intelligence, social competence, and other non-health related issue. What the company does is, and then you can say it's right or it's wrong according to your beliefs. Each one has a position. People feel strongly about, we had some that were even much more strongly, especially when they touch very practical things and very actual things of human ideology. And I'm, of course, not interested in any moral conversation of this. I'm just interested in what goes on in the decision process that makes us conclude what we conclude. Each person will make a different conclusion. And the idea that we may be more malleable and that all of us may be not seeing as much of the space of argumentations that we think we are, and that when we get together with someone that thinks differently, then we may change more than we thought. This is what I will try to show you. I have 3 slides to make this. So this was the distribution of this particular population. This was a TED. This is nothing universal. It will change in with people of different ages, people in different places. It's just kind of a norm. So you see a lot of people were 0 means this completely wrong. And you see this here, 10 means it's completely right. And you see that in the same space with people that more or less have the same background and so on, you have this diversity of someone sitting next to another one, that one thinks that it's completely wrong and the other one thinks it's completely right. And the question is, we will put these people together in a group. And we will ask them to think like they're in an ethical committee, and their job is to come up with an consensed number for this, like saying, well, we give it a 4 or we give it a 6. Like, it's not completely right, but it's. And the important thing is it has to be unanimous. So it's 3 people. The 3 of them have to sign the paper and say, I think this is the right thing to do. And they all have the option of saying, no, I do not want to sign this. And they have this kind of opt-out. And so the question we're asking here is not so much to what consensus they reach, as the question before, although we also asked this question. But the first interesting question here is, what is the likelihood that they will reach consensus? And for this, something that you have to know, which is important, is that people, in the same way that they distribute their opinions on whether it's right or wrong, they also distribute their confidence in a way that is kind of predictable, which is that people that are in the extremes, they're very sure of the position. And the people in the middle, which we call the grays, they doubt more, they are not sure, and so typically their confidence is way lower. But you may see here something which actually is true in all the dilemmas. It's small, but it's true, which is the people in the center, in the very center, they have higher confidence. And this is because there is a bimodal distribution in which there is a population of people that are in the center, but have very high confidence. And we call these people the high confident grays. Those are the people that think, this dilemma has real reasons for being right, real reasons for being wrong. And I'm really sure that the right thing to do is to stand somewhere in a central place in this space of options. So here you have like the distribution of confidence for people. Some people have medium confidence, and these are the high confident grays. So now, my last slide, what happens when we put these people together? And of course, the likelihood, and the question is, what is the likelihood that they will reach a consensus? And of course, if we do this as a function of their initial disagreement, and of course, if the initial disagreement is 0, meaning that they had the same ideas, then they naturally reach a consensus. It's very simple. You think it's wrong, I think it's wrong, or you think it's right, I think it's right. We just sign the paper and we go out very rapidly. And of course, as there's more difference, this decreases. That's natural. Nothing that it's highly expected. The real surprise is that this value, even with very high disagreement, is close to 50%. It varies in the question, goes from 20 to 60%, but it's always 1 order of magnitude higher than what people think, if we ask them, is the likelihood that they will reach an agreement. So if I were to run this experiment mentally, and I would ask, which we've done, and ask people, what do you think is the likelihood that if I put someone that thinks this is completely right with someone that thinks this is completely wrong, like if I build 100 of this group, how many will reach agreement? People will say 1, 2, sometimes 0. And reality is that in the right condition, people speaking and listening in an open situation and not too many people shouting, then the likelihood of getting together, of agreeing to a consensus and to depolarizing is much higher than what people would expect. Once again, conversations converge to rationality and not to rationality when they are in their natural habitat, in the right domain. And the last thing is, okay, 50% of the groups, but what is it? Why some do and some don't? And the answer to this is the most important factor is whether there is a high confident gray. If there's someone in the group that can speak to both parties and say, you're right, but you're also right. And look, what he's or what she's saying may have some reason so there's someone that understands that it's not idiots against intelligence in whatever side you want to see the balance going, but people with arguments from both sides, then the likelihood of convergence increases substantially. You see, not huge effect. It's not like they guarantee that there is likelihood of consensus, but they increase this very substantially. These experiments have been done. So this is a laboratory experiment, but many people have done these experiments in the grounds. I think the most interesting experiments are done in the frontier between Israel and Palestine with the exact same results. You put together in the moment of most ferocious fights, in a situation where you think there's no way these people, will understand. You put like the most radicals from one place and the most radical from the other place, and you make them talk. And if there's a high confident gray, that actually gives this perspective of malleability, the idea that, take out of your mind that people will not change. They may change because you're thinking in this way. Then groups now in the real ground, not in this kind of moral simulated experiments, are much more likely to reach consensus. And not only that, but also if you measure the likelihood of participating together in collaborative work, in working in the same enterprises, future behavior of these people, it's a complete game changer. So I think that there's something interesting. I'll close with this, but I began with very sophisticated technology, fMRI to go into vegetative state patients and preverbal infants and so on, and how this can help us, give us information to make very difficult decisions. Then I went on to say, well, but this is not the majority of decisions. Of course, the decisions happen just very rapidly, fast and furious decisions, and we make all these sort of errors. And in the end, instead of going skeptic on this direction, which I think we feel very skeptic, I wanted to give a note, not from fake optimism, but data that we've been gathering for many years, that I think should give us at least the idea that this pessimism of the incapacity of conversations to solve situation comes from the fact that typically we have them in the wrong setups and not where they should be. So with this, I thank you very much, and I'll take all the questions that you may want and have. Thank you very much.
Thank you very much, Mariano, for that fantastic talk. I have lots of questions myself, but we open up to the audience. Please feel free to type your questions in the Q&A. And as people get ready, if I may, I'd like to ask the first question. So I really, really liked your point about how some of these conversations are sort of happening in the wrong spaces, and that we need to find smaller groups where sort of more malleable opinions can actually be heard. But I was curious, from what you say, it sounds like, the success in sort of this convergence and consensus making requires a few persuasive mediators who can talk to both sides. So how do we inculcate such a temperament? How do we get people to be more sort of to have that frame with which they see issues? Do you think it's in educational systems we can do something, or as a society, or is it really an individual?
This is I think a very good and from my view at least very relevant question. It's been very highly studied, mostly as you bring in your intuition in educational setups. So this is typically referred as malleable minds, or as growth minds is the typical term. Like if you were to look in Google Scholar or for references, the right term would be a mind of growth or growth mind. And the typical problem is, it's like you give a 10-year-old children a problem that's just above what they can do, so that they cannot solve it. And that's typical of science, right? In science, we get problems that are just above from what we can do. And children split, of course, it's a continuous, but they typically split in two modes of reaction. It's not a completely categorical split, but there are like two tendencies. One is frustration, saying like, I cannot do it. It's too hard. And this leads to a whole lot of behaviors. They cheat, they blame others for giving them things that they cannot do. So they build anger and so on. And other children, naturally, those things vary as there are variances in height and eye color and so on. There's variance also in this disposition. Other children understand that they cannot do it, but understand that they can get close to it. And that's why it's a mindset of growth, because they understand that they can do something to break this leap between where they are and where they have to be. And so this stretches them. So same problem to very different trajectories. And what has been, once again, widely studied in educational setups is that this ends up being very decisive in educational trajectories. So children that do have these mindsets, they persist in them, and they start also to bifurcate, because they start being outsiders, and the ones that do not pass the exams, and the ones that start believing that they cannot do things, and they build anger and so on, while the other ones are the ones that end up going to the good schools and so on. Now, what the good news is that, and that's the response to your question, is that these things can be changed. It's not easy, but it's also not so hard. So it's not so easy. It's not just a disposition. It's not just like saying, I want to have an open mindset, and then bloom, next day you will have it. We have kind of these cognitive illusions, but this is not true for any form of learning. It's not like I want to play tennis and next day you play tennis. You have to train it. In the same way, if you want to have an open mindset, you have to train it. but it's much easier than playing tennis. That's the good news. I mean, it takes, some, and there are many different ways that have been developed, once again, mostly in educational setups. And it's been proved that if children in time, you change them a fixed mindset to an open or to a growth mindset, then they are in time to have a better likelihood. Those things, of course, are always probabilistic, but they have a higher probability of going through a much better educational trajectory.
Thank you. But so it sounds like this has to be instilled as an aspiration, even for the kids that don't naturally have that temperament, that this is what.
Yeah, it has to be. You have to, and this is trained. It also, many times parents, because it's not like it's not something that you have to learn, because some people have it granted, right? And other people don't. So it's not like there's a default for this. And then you can go back on why this happens. And some of these things may be genetic and so on, but some of these are also very early implicit training. So parents building this mentality in ways, not in ways that they understand, sometimes completely against their will and their desire. So there are different things. This is a very complicated literature. So it's not like there's a simple way on how to build this mentality. I think I'm pointing you to the idea, and it requires study. I think it would not be fair if I say I can summarize this in 2 minutes. But some ideas we can put in the table. One that has been known in pedagogy for a long time is people get frustrated when they have aspirations which are ridiculously high, and different educational setups work differently in this condition. So one condition is you're always kind, and there's a very famous pedagogical idea by Lev Vygotsky, the Russian pedagogue, which is the zone of proximity. So it's the idea that learning has to be just above, but just above. In these problems that I told you, they are not just above, they are like a significant step above. So those are the ones that can frustrate you. And that's not where you should typically have children grow in their educational setup. So this is one reason that will make a lot of children make the conclusion that they cannot solve problems which are more difficult than they can afford, because they've given problems that they really could not solve because they were so difficult that they have made this conclusion because of a wrong sampling history of problems. So this is just one idea of how you can begin biasing, falling in one side of the camp or the other one. It's complex, but there's substantial literature, and I think that it's one of the cases in which we can make informed policies, both at like large public policies, but also in parental policies, like how to grow our children in a better way.
Thanks, Mariano. It also sounds like this is the kind of thing that you would have to persistently reinforce as well. You would have to keep reinforcing.
Yeah, and also that's why I'm making always the point that it's complex. It's also domain specific. So some children may have, they may have some domains in which they have this mentality and they know they can solve them, but they are bad in maths. And so suddenly in math, so as I was saying, intuition, it's not like there's people with good intuition. People have different ways of relating with adversity and with resilience in different domains. And then one thing which is also very important to know is that, and this comes from a very basic idea of so I said, I made the case that we make very rapid conclusions, which we trust a lot. But it's even worse than that, because then these conclusions begin changing us on a way that we confirm the conclusions that we've made. And this happens individually, but also socially, because we tend to look for data that confirms the hypothesis that we have already made. So imagine you're in a point of bifurcation where you can make the claim, I'm bad at math or I'm good at math. And you're right there, and you'll make your claim. Once it's like a bit like measurements in quantum physics. Once you've made this call and you say, I'm bad at that, then you've changed reality. And because once you've made this call, this is what I like. George Soros, the finance. He was a study. he studied with Popper, and he knows a lot of human behavior. And this is why he's made a lot of money because he understands how people behave in a very deep way. And it's interesting because in a way, I think he thinks of the stock market as the best laboratory of human behavior. And he keeps on coming on this idea, which he calls reflexivity. It's not a new idea, it's an old idea, but it's very powerful. And he says that this is one of the central ideas in the market is the market makes a belief that an action is the stock is going to grow. And this decision that the market has made changes reality in the way that now this stock changes because people will be consistent with the idea that they've made. So this leads to financial bubbles. There is a moment in which there is an inconsistency between people's beliefs and reality, and then there's kind of an explosion. The idea I would like to bring here is that we also have the psychological bubbles. Like we tell to ourselves a story, I'm good at this or I'm bad at this, and this story builds because we sample data in a way that we look for consistency on that. Eventually, sometimes it also blows, but for a long time, it gives us the ability of having completely different mentalities. So this is also very important. Sometimes parents, they are not also aware, like sometimes statements are very heavy, like saying he's not good at math, or he's like, I'll tell you one that happens to me. Like my son, he's the one that tends to, he falls a lot. I mean, he's, this is also a typical behavior. So like if they go to a party, birthday party, and one falls and has like an ache in his hand, typically it's my son because he's kind of not the best control and so on. And sometimes I'm very versed on this, but sometimes I make the error of, making kind of the caricature of this, making fun of this and making, once again, it's, like when with this, I know theory tells me that I should never do this because the only thing I'm doing is I'm fueling more something that actually begins being self-consistent. So what I'm saying with this is that sometimes there are very strong biases that are difficult to eradicate. They take like substantial attentional control, not to fall onto these errors that parents often fall to stigmatize even their children, which is the last thing they would want to do on earth. But sometimes we do nevertheless.
Really insightful. Thank you so much, Mariano. Going back to something earlier in your presentation from one of our frequent participants, Jenny, she asks, is the Bubakiki correspondence a form of synesthesia? And if so, does this tell us that everybody is capable of developing synesthesia?
Yeah. So yes, it is. So for those that may not be familiar with the word, synesthesia means that there's kind of a automatic relation between different sensory modalities. And so some people, when they see some shapes, they as we saw here, they believe that they correspond to certain sounds. But there's also some people that when they perceive certain tastes, these tastes produce certain sounds or they relate to certain shapes. So vision, audition, taste, smell, which normally are independent modalities, they're automatically linked. And what this experiment shows is that we all have certain forms of synesthesia. Some of those are cultural. For instance, another example would be color and temperature. Most of us think, those things a priori are independent, but they're not. And the reason they're not is because they're a material correspondent, which is the majority of materials when they're incandescent, and hence they're warm, they're red. And so we tend to think that red is hot and that blue, which is more the color of ice, is cold. And this is a form of cultural synesthesia, which is driven by material experience, like the one I showed with the mouth. Another example, which I really, really like, and it's in my book, Priya, which you mentioned, so you may have read about it, is the correspondence between time and space, which a priori are different entities. But the majority of the people, and if you think like how we use language, is you feel like Christmas is approaching. It's approaching from where? Like it's Christmas is in time, but we have the feeling that it's ahead of us. The future is ahead and the past is behind. And this seems like that's just how it has to be, like Kiki and Buba. But there are other cultures. I mentioned the example of the Aymaras, which is a culture in the northwest of Argentina and Bolivia and Chile. And this culture has in their language the word for in front also means past. It's the same word. And the word for behind, which is naira, also means in the front. And it's very interesting because the Aymaras, what they say is that the reason the past is in front is because it's the only thing we know. And there's this relation between what, like when you want to tell someone, did you understand someone? You say, you see it. Like seeing is understanding, seeing is knowing. And so if you use this relation, the only thing you see, the only thing you know, the only thing you understand is the past. And the things that you do not see, do not understand, and you do not know is the future, which hence is behind, it's in the back. And so it's very interesting because we believe that like this correspondence, synesthetic correspondence between time and space seems very logical, like the future, we advance to the future. That's how it should be. But someone comes in a different culture, then you know what, for me, it's the other way around. And there are many other ones, like the Aztecs, they have circular time. And so now it's not only different correspondence between what's ahead and what's behind, but also in the topology of space. Interestingly, there's also not complete freedom because all cultures known use one-dimensional representation for space for time. And that's very interesting because it seems to be, as far as we can tell from the way we perceive time, that this is a physical limitation of how we can organize a certain space. So there are many, many examples of synesthesia. Also very interesting, just to tell an anecdote, I think it may be, because Edward Hubbard and Ramachandra, which I mentioned in their paper, they were kind of the founders of the neuroscience of, not the founders, but kind of doing a lot of the interesting work of the neuroscience of synesthesia. And Edward Hubbard we did some work together and we were very good friends. And the problem with working with synesthetes is that it has this flair of genius, right? So musicians, they claim that they see music, and this gives brilliancy, it's like, or mathematicians, a great mathematician will tell you, I can hear the sound of pi, and hence I'm, I'm not just like the product of work, I'm the product of genius because I have like this very sophisticated, so it gives like a kind of a sense of poetry. So people lie on this. And so you get a lot of people that come to the laboratory saying that they're synesthetes, which they're not. And there are very interesting tests to measure whether someone is genuinely synesthete or not. For instance, one is typical synesthesia is people see letters of different colors. So like L's will be blue and A's will be red. And so you say, okay, perfect. So now do the following. And you give them a maze, which is full of L's and there's one A. And if you're not synesthete, this is very hard because it requires a lot of attention. But if it's red on green, then this just pops out and it's very rapid. So some people are real synesthetes, and these people, they just, can find it, in a fraction of a second, independently of how many distractors there are and so on. While some people claim they are synesthetes, but then in truth they're not. And there are many, many more interesting stories about synesthesia, but it could go very long.
That's fantastic. So there's a question from Victoria who asks, how has information from the Myers-Briggs personality evaluation been incorporated into any of these studies, if it has?
Can you repeat the question? Because I'm not sure I understood it.
The information from the Myers-Briggs personality evaluation, has that been incorporated into any of these studies?
I don't know. Sorry, I'm not. I don't know this. I cannot.
Yeah, there are these personality tests that you can take that cast you into certain combinations.
Yeah, but I this is a research. I would not like to speak about something that I'm sure there is information on that, but not that I'm aware, and that's kind of the limit of my knowledge. No
worries.
I would be speaking colloquially. That's not something that I know sufficiently to provide an informed answer. I'm very sorry.
No worries. One of our fellows, Tyler Lutz, asks, are there still confident gray positions for situations in which there is no natural middle point? What happens, for instance, if you ask groups to point towards Vladivostok or guess in what direction the hour hand on the clock there is pointing?
Yeah, this is very interesting. This is very interesting because we've not done the confident grace on problems like this sort that have a concrete and real ground truth. There's a solution, and they have particular distributions where they're Gaussians, they may be shifted, or we the confidence grades are, I think, interesting in problems in which the distribution of beliefs is typically by model. And we've shown actually in a specific paper that how people build confidence on these problems and how people build confidence on perceptual problems, like pointing to Vladivostok, leads to very different distributions, which leads to very different ways in which confidence is being constructed. And essentially, the main difference has to do with the idea of from what's the universe from which they sample data. And typically in polarized problems, it is as if this is a model. So this is a very simplified model, so that I'm not speaking exactly how it works in our brain, but a model in which you let people sample from two different distributions, arguments. So you have arguments like imagine the genetic problem I gave. So the arguments in favor would be, we try to make the best for our children, and when we use the arguments we have, we use education. Why not use genetics? I'm not saying this is right. I'm saying this is an argument. An argument against would be like, this will lead to, Aryan, like the kind of typical eugenic nightmare, right? So we will all converge to monochromatic humans. And what I'm trying to say is that those arguments, you see, they're very discrete, and I could pick many more, but they seem to be picked from their very different bags. And so it builds a very model distribution in which you may have a number of arguments from this bag and a number of arguments from this bag. And then people that are the high confidence grades are the ones that actually sample from both of them. And the ones that are the low confidence grades are the ones that actually have very low sampling. So essentially, they don't understand the problem, and they think it's just too complicated, and they don't want to think about it. It's a very different perspective. So I don't think the high confidence grade argument would work for unimodal distributions, like in the problem, I forgot the name he or she mentioned, like the pointing to Vladivostok problems that are typically perceptual problems. This has not been shown, and I don't think it would work there. I think the intuition is right. I think we have a good reason to understand why it would not work, which is again, its confidence is constructed very, very, very differently in these kind of problems.
Thank you. Next question from the audience. Can you tell us something more on the shaping of reality generated by a claim that we do? It seems that we convince ourselves of something, and then we subconsciously make decisions that confirm the claim.
Yeah. So let me give you an example, because I mentioned the wrong conversations from Twitter and so on. There are a lot of correlations between the actions that we make and the beliefs that we have. So it's been known for years that people like, and actually we just have a paper on this, people like other people that think like them. And this is very universal, it's very conserved. Of course, you should not take this argument as you will not like someone that thinks differently from you. It's a statistical argument that we tend to like more, we tend to prefer, and we tend to have many, many more friends. Actually, each of you in the audience can do the experiment. How many people around you do you have that think radically differently from you? Like in first question, second question, take 15 different problems, like, taxes, abortion, drugs, foreign policy. I mean, take a number of them and think how you think about all of them, and think how the majority of the people think about these people. And if you're like the majority of people, you'll find a very strong correlation. So you do agree on a lot of problems that when you think about them, they are really independent problems. I mean, me being liberal on this does not imply that I have to be liberal on this and I can be conservative on this other, but we tend to be kind of very partisan. And we tend to be, when I say we tend, is a statistical finding that the vast majority of the people are like this. Interestingly, those are experiments done in sociology. The more educated the people they are, the more correlated they are. So if you take in the US the axis of what Democrats think about a particular problem, what's like the typical Democrat reaction to any particular problem, and what's the typical Republican, this is 20 years ago. Now Republican, I mean, it spreads in axis, but typically when really there was like a two-dimensional layout of political spread, most of the variants in the US. And then you spread people in these domains, and you ask how much people look alike, how correlated they are. And you measure this as a function of education. the more educated people they are, the more correlated they are, the more they begin to think alike, because they form these tribes in which, why is this? This is a response to your question, because they are intelligent people. We are, I speak in third person, but I make all these errors. I'm not excluded from any of these. But we tend to listen arguments that we unconsciously gather to confirm our beliefs, because this is very comfortable. How this happens, we did one study, which I think, at least to me, it was very enlightening on the complexity of this problem. Because this is true, of course, this is worse in social networks, because people in social networks follow who they want to follow. And so they get a lot of evidence that confirms what they want to do, which is true. Take vaccines. I'm vaccinated. I'm completely in favor of vaccines. Here I'm going to say my call. It's not important. But if there's information, some information that shows that vaccines do have a risk. And the obvious fact for this is that, for instance, I'm sure I want to vaccinate myself. I do not think I would like to vaccinate a 6-month-old baby. And this is just a recognition that I understand that there are arguments against it. In my opinion, the arguments in favor are much more sound, and hence I make my conclusion. But if I only were to look at these arguments, and this is once again, the only space I'm looking for, I will rationally make a conclusion that this is the wrong thing to do, because I do have papers and evidence that show all what I want to see, that proves that I have to stand where I do stand. So how does this work in social networks? There are fact-checking companies that understood this problem, and so they said, we need to provide balanced evidence. We need to provide evidence showing that, like, the good people do good things, the good people do bad things, the bad people do good things, and the bad people do good things, so that people understand that reality is more complex. Perfect. Now, what happens? You can see this as kind of a distribution of evidence, right? So evidence in favor, evidence, the bimodal evidence I was saying, you could think about vaccines. You should vaccinate because of this, but you should worry because of this, but you should do it because of this, but beware with that. And it's providing all the evidence. Now, what is the problem? The problem is that these companies have, like, say, 1 million followers. But then the followers of these companies retweet or reshare the information that they get to 50 million people. And these 50 million people do not receive directly from the fact-checking company. They receive it from who they want to receive it. So it's kind of like a rectifier. So this company is showing information, balanced information, but then there are rectifiers, social rectifiers, that filter information and only let this one pass, plaque. And there are people that are downstream from these rectifiers because they have this belief. They have the belief that vaccines are wrong. So they only follow people that provide information that confirm this vaccine. And they get more and more convinced. And once again, I want to make the claim, it's not like they are thinking wrong. They are thinking on the wrong subset of the data. And this is wrong. But restricted to this particular constraint, the conclusions that they often make are the right conclusions from just looking at a small subset of the data. So this is a very, very clear example of how, once you have a belief, you decide to sample data on a way that only confirms the belief that you had, and you gather real data that actually will prove more and more that you are right to think that.
Right, and even when you have a broader set of data available, you gravitate towards the bits of data.
Yeah, this is also very typical, that even exactly this is very important what you're saying. People, and this comes from and this is, we tend to think this as irrationality, but this is in the essence of science. When we make, like, the typical scientific claim of great claims imply or require great evidence. Like, if I want to say that the speed of light is not constant, then I really should have a lot of evidence. Why? Because we have a strong belief, a strong prior, if you think this as Bayesian thinking, like I do have a lot of aggregated knowledge that tells me, so if I do have information of the same value in favor of what I have a strong prior and against what I have a strong prior, Priya, you're saying I will not weigh them in the same manner. This is exactly what you would expect from a rational Bayesian thinker. This is the thing to do.
So there's one more question that I want to take, which sounds intriguing. So the question is from Brad in the audience. He says, thank you so much for your presentation. So your response to that MBA question about personality types made him curious, and he wants to know, how has your work been received by psychologists working on emotional intelligence. So the president of our university, Peter Salovey, is one of the sort of originators of this idea of EQ and emotional intelligence.
Yeah, so this what I mentioned there is not my work. So today I was kind of careful of saying what part of the research I showed was my work. The work on the two papers on decision making were my work, but then the extension of these two educational setups in malleability frameworks and so on is not. A lot of famous people have done this, but this is not my work. We've done work in education, showing same ideas, but not exactly this. Now, in terms of so I don't know the answer. The answer is that because this is not my work, I don't know exactly how it would be received by, but because I would like to respond, I kind of want to respond tangentially to this question, to something that I think is a bit related. Emotional intelligence, like general intelligence, like IQs or EQs, they're very controversial, and I think we all understand the reasons. Like for instance, now there's a group of researchers that I think that the champion of this research would be Lisa Feldman Barrett. She has a very interesting book called How Emotions Are Made, and I think she would be a very good speaker for this symposium. She makes a very strong claim that emotions are completely different than the way we think about them. And in particular, she makes the claim that in the same way that I told you that, we think that the future has to be ahead and the past has to be behind, that we think that, this has to be anger and this is happiness. And she claims that this is wrong. And she claims this from data. It's not and her data is that actually, if you look at the typical tests used for emotional intelligence, which is our ability to separate this from, this that would be sadness, are kind of very strong cultural conventions that have very fuzzy mappings, much more fuzzy than it has been claimed. They are different in different cultures. She claims it's not true that all babies express them and understand them. It's not true that, so there's kind of a controversy. And this controversy comes, in the end, I think, in an issue of definitions. My point there, both for IQ and for emotional intelligence, my understanding is kind of a broad view of all the data. And I think, and I think that all the data shows consistently that there's some consistency between how people express emotions in different cultures and in different traditions and in different ages and different backgrounds. But also, it's not completely universal. There are exceptions. There are very clear exceptions. Lisa Feldman Barrett has a very nice example. She shows the face of Serena Williams when she won the US Open. And she's like, and if you see that, she's like really angry, but she's not angry. She's in ecstasies. And she says, like the intensity of the emotion, we confuse them and we can kind of reappraise this emotion and re-understand it and re-signify it in a completely different way. So I think that my impression, and here I'm saying my impression because before I was saying I think what the paper said, but now it's a space in which the papers say different things. This happens many times in science, and when this is the case, I think that you have to understand that there's more variability and more complexity in the distributions and more lack of understanding and clear definitions that builds this incompatibility. So this may be, sorry, a bit of a long answer, but it goes down to say that I think that part of very big discussions between these fields in the end are because we do not have yet mature and good definitions of what an emotion is, of what sadness is, of what emotional intelligence is. And so whatever attempt someone makes to do it, like the examples you were making, or like Ekman and all the famous examples, are prone to failure, like all science. I myself, I'm very sympathetic because I think they need to be done. and it's an approximation, and they will fail, like all scientific models have failed. And this one are more likely to fail against because the territory is highly variable. And so I think we have to pursue this direction, but not stubbornly, but understanding that as all scientific model is the best approximation that we have. It's kind of the best that we can do with the data that we have. We hold it. We have to be open, like once again, malleable, and understand that we have not to stick religiously to it because it's our baby model and the one we constructed. But in the moment that it does not hold to the evidence and there's sufficient contradiction that we need a better model, then it's time eventually to change it.
Yeah, no, I think you've captured very nicely sort of the provisional nature of knowledge in science. Basically, what you know at any given time is the best to date and has limitations, and you have to be aware of the limitations. And therefore, you have to be willing to change your mind as you get better data, more evidence. As you said, you have to build a more refined conceptual model. So I could keep going on. I have so many more questions, but I think we need to close with one final question, which is Jenny Wagner asking again, following up on the bifurcation of decisions, is there any neurological reason why any change of decision after the first one has been taken happens more often abruptly instead of slowly? For example, going suddenly being good at maths after all when having solved one difficult problem?
Yeah, I'm not sure. There are two. I saw two different answers to this question. I'm not sure either of them is the exact one. But so one thing is there's a lot of, because she mentioned like the brain evidence. So far, I've been speaking about psychological evidence. So there's a lot of neural evidence for all what I've been describing. And this comes from a kind of a way that a lot of neuroscience has changed in the last years in how decision-making progresses, which is on a highly Bayesian strategy. So there are many demonstrations. Alex Pouget, for instance, in Geneva would be, I think, that the best person to look for this kind of information, showing that you can account for a lot of strange things in decision-making if you look at the neural circuits as doing Bayesian computations. And this is the essence of kinds of the self-fulfilling prophecy, because it's you make a prior, and once you make a prior, you sample evidence prior, as you exactly described it, in an unbalanced manner. So there is neural evidence showing that once you've committed to a decision, then neural circuits change on a way that they decide differently. It's not a magical construction. This is implemented on a way that we understand in neurons. The second thing is this idea that then there's kind of a roll-off of these decisions being much faster. And here I think, at least what comes to mind to me, I'm not sure this is exactly the answer you were looking for, but people have studied this very nicely in the history of world sport records. So there are many records that have not been broken for years and years and years and years, and then eventually they're broken. And once they're broken, there's like a very rapid repetition. So the cleanest example is running 1 mile in less than 4 minutes. I think that's which was kind of no one could do it. And then 40 years ago, someone did it. And since then, there's like 1,400 people that have done it. But before that, for 40 years, no one did it. And so, of course, there's an issue of technology, but it's not only technology, because it's really this game changer, this bifurcation. And the explanation for this, once again, is only the force of the mind, of our own minds, to convince ourselves of what we can do and what we cannot do. And I would like to temper this, because it's not like I say I want to fly and then I fly. Like this is by no means, it's obvious, but I want to state it. I mean, it's not, I'm not predicating here that dream about something and it will come true. This is not the case. People live in very bad realities and they struggle and they cannot do better than they do. But this said, there is much more margin than we think for the range of beliefs, for the reasons I just explained, in our own performances and in our own decisions, on a way that once we understand that something is doable, and so the belief that it could not be done is eradicated, then this is a game changer that then builds on a rapid cascade so this is an example from social sciences, so to say, but I think it's the best example for the psychological question that you were asking.
Great. Thank you so much. That just absolutely fascinating talk. And thank you so much for taking the time to thoughtfully answer all these questions. I really should draw it to a close because we are over our time. Thank you so much, Mariano, once again for coming and giving us this wonderful talk, very thought-provoking. And hopefully we all leave here aspiring to have as malleable a mind as possible, right? To make our ways in the world. Thank you so much. So let's give Mariano a real round of applause, virtual applause. Yes. Thank you.
Thank you so much, Priya.
Thank you, Mariano.
Thank you.